So this talk's on the .NET configuration. So there's quite a few things we want to cover through this, and it's hopefully cover like pretty much everything to do with the kind of the .NET configuration library in the new .NET. There's some stuff about me. Pretty much everybody knows me here anyway. But I work at a company called Excellence, and we are hiring developers at the moment, like every other company out there. So we're hiring kind of juniors to seniors, so anybody in between. So if anybody fancies anything like that, feel free to reach out. But I mostly work in C# and JavaScript, and I run the two user groups, obviously this one and the one in York. So today, hopefully we're covering all this stuff. So we want to cover the basics of .NET configuration and kind of what underpins it all. We want to go into the providers and how it can get its data. We want to go through the defaults of like the web host builder and kind of what we get out of the box with ASP.NET Core. How it can utilize bindings onto more complex objects and also IOptions. And then we'll go into like dependency injection and how you can like inject it into the kind of normal standard kind of flow of kind of your dependencies. And also a bit of validation on kind of configuration as well. I don't need to click that. So the basics. So we're not going to be talking about system configuration, which is the old .NET framework. We're not going to be talking about the system.configuration.configuration manager, which is the NuGet packaged version of the old .NET configuration, which is targeted to .NET Standard 2. And that includes like things like the configuration manager, which is the .NET 2 and .NET Standard stuff, and configuration settings, which is the really, really old school .NET Framework 1 and 1.1. And if you're still using that, then you probably want to cry in a corner. So that means we're not looking at any of this XML loveliness. But what we are going to talk about is the Microsoft extensions.configuration.abstractions. So these are a bunch of abstractions like the login abstractions and things like that, what Microsoft provides in the new kind of framework. So they kind of complement the login abstractions, the caching abstractions, the dependency injection abstractions, and localization, and I think there's a few more now as well. But we're going to look at the implementation version of the Microsoft one. So if you wanted to, you could actually build your own configuration provider, own configuration module, which adheres to these abstractions if you wanted to. So your company could do it if they really wanted to waste some more time, or use yourself on your personal time, you could also do it as well. But yeah, we're going to talk about the Microsoft one. And one good thing about the Microsoft one, I think the .NET configuration ecosystem in how we configure .NET apps has been pretty atrocious in the past, I think. So there's just that big XML file with no kind of discrepancy between like production or kind of development or staging, and it's been really hard to kind of wire in extra parameters into there. And then people have built extra things on top of that. So I built I think it's called Humble Config package, which provide config through environment variables like the .NET configuration stuff, through Mongo, through SQL, and some bits of other bits and bobs as well. So you could pull it in from different sources and ones or overwrite other ones. And I think this is where Microsoft did a really good job of looking at the rest of the ecosystem in software development and seeing how everybody else like Node and Java and everybody else did all their kind of configuration and combined together and made something really good. So the Microsoft extensions.configuration stands on top of the .NET Standard, so that means it's compatible with the .NET Framework, .NET, .NET Core, Mono, Xamarin, Maui, UWP, Unity, whatever kind of supports .NET Standard, it will kind of work with, which is great. So it implements the abstractions which Microsoft provide. It's all installed by NuGet, and if you use ASP.NET Core, you get that in for free because it pulls it down anyway. It has a concept for configuration providers where you can provide the data for it, and we'll go into that later. And by default, it has an in-memory provider. I'm going to grab some water because my throat's going. So, and then also it allows you to do callbacks as well. So if you remember the old .NET configuration with the XML files, anytime you change the XML file, you'd have to restart the app, or the app will have to restart in IIS for you to get the new configuration changes, which would take your site down for a bit, or it might make it slower while it recycles that pull, etc. And the configuration now has this way we can like listen to callbacks and refresh our app and do more intelligent things when the configuration changes. So it's really simple, and it's just a key value pair. So we have a key, like key 1, and the value of value 1. And I think, is this actually right? Oh, it just does my mouse cursor. So you can do the key 1, key 2, key 3, key 4, key 5. And if you ask for one of the keys, it'll give you back the value corresponding to it. So it's pretty simple. But it can represent hierarchical structures, which is quite nice. So like our old XML files, we can represent a hierarchical structure by using like a colon. So this bit here, where we've got the colon, so we've got Twilio base URI and Twilio app key. So they'll go under Twilio, so it kind of ends up more like a hierarchical kind of object. But under the hood is just flat keys. So an example of that, you could have like parent 1 and key 1 in that example there. All the keys are case insensitive, and this is to make compatibility between different systems. So if you're running on a operating system where all your environment variables need to be uppercase, it doesn't matter because this will take care of it because it doesn't care about cases. It's all case insensitive. So the basic setup code that you need to get this working is you create a configuration builder and call build on it. And that will give you some config object to actually pull configuration out of. And for this example, we're just going to plumb in a dictionary to add an in-memory one. So if you wanted to access a bunch of in-memory values, you can just do add in-memory collection and pass in your dictionary values like that. And the in-memory collection is actually really good because you can use this for testing. So if you've got some like kind of integration testing and things like that, you can just plumb in some extra values at the end of your configuration pipeline, and it'll override everything that's there. So to get the values out, all you do is use the indexer and pass in the key. So we can do configuration key 1 and parent 1 key 1, parent 1 key 2 like that, and that'll get you the values back as strings. So we can also get back sections as well. So it knows about the hierarchical structure. So we can say, go get me the section of parent 1. We can pass that along in some code somewhere. And then in that other bit of code, you can say, go get me key 1 and go get me key 2, and it'll get you them values in that configuration. And as I said, you can do reload notifications. So if your configuration reloads, you can make it do something. Maybe you want to pop up, and maybe you're using WinForm still, you want to pop up a box saying like, oh, your configuration's changed. Click OK to refresh, and you could do something like that. So you can get this reload token. So you ask the configuration for a reload token. You register callback with it. So we're just going to do a console write line configuration changed. And then we can call force reload. So the providers can do this, but you can also do it yourself. So you can say force a reload, and then that'll output configuration changed. But if you try to reload again, it won't output changed. And that's because you need to re-register the callback every single time you reload the configuration. So I'm just going to show you that like a little demo. So can everybody see that okay? Excellent. So this is our values here. We've got, actually I'm just going to open a terminal and browse to here. There. So I'm ultra big. So this code here is we're creating that dictionary like we said before. We're plumbing into some that in-memory values into the configuration builder, and then we're just writing out the config saying key 1, key 2, key 3. So that should output value 1, 2, 3. So if we run that using dotnet, just to maximize this, dotnet run. We'll get some warnings in some of my code's not used, and then we'll get output 1, 2, and 3. So it can read that value straight out of that configuration there. So if we just comment that bit out, and then we take the section stuff. So this goes and gets our key of 1, the section, wait a minute, I don't want that bit. So this goes and gets the section of parent 1, and then gets the key of key 1. So that should get us this one here, value 2. So if we go run that, we'll get the value 2 out there. So nice and simple. And then the next one is the callback, to see this working. So this registers a callback, gets a reload token, register the callback, and then it does a console write line to just say the configuration changed. Then we just forcibly reload it twice. And this is just to prove that we only get that bit of configuration changed once. So there we go, you got the configuration change there. So nice and simple. Next slides. So I'm just going to go over the configuration providers, and this is how we've got the memory one that we can use, but that's not very useful if you want to have a load of settings on your disk or in environment variables. So this is where configuration providers come into play. So there's tons and tons of them. The ones what I'm going to cover is the file configuration one, the environment variable, and then the user secrets, because these are kind of the default ones what you get wired in for you. But there's also ones which is a command line configuration provider, the Azure app configuration provider. So Azure has a way of storing all your configurations in kind of their little database, and you can connect to that, and it'll automatically refresh when you change the values. There's also one for the Azure Key Vault as well. So if you're storing lots of keys in there, what's the secrets, and you've only got certain permissions where you want to kind of allow people to access them keys, you can put them in there. And AWS has the same ones as well. So there's AWS System Manager, which is the same as the Azure app configuration, and there's also an AWS Key Vault, AWS KMS, which is the same as Key Vault for Azure. And there's loads of other different community provided ones as well. So there's things to do, YAML, TOML, tons of different ones, and you can write your own if you really want to. So we've already gone for the memory one, so I'm going to skip over that one. The file provider comes in a bunch of different NuGet packages, so they're all separated with their own NuGet package, so they're all independent. There's a way to do ini files, JSON, and XML by default, and you can register them like this. So you do add, these are all extension methods on top of the configuration builder, and so you can call add ini file, add JSON file, add XML file, and then pass in the file name into it. It has a parameter of optional, so if it is optional and the file's not there, it won't throw an exception when it builds. If it isn't optional and it isn't there, it'll throw an exception as soon as the app starts up. So if you want that kind of security of like making sure that configuration file is there when your app loads up and it doesn't go to anything else, then you can forcibly kind of make it throw an exception. All the file providers also provide a reload on change. So as we have forcibly reloaded the configuration before, these providers can do that for you. So if you change your JSON file and you've got the certain reload on change true, then it'll automatically get the new configuration values into your app. So this is kind of how they're laid out. So an ini file, if anybody runs these kind of old school files, you have kind of sections which are denoted by like the square braces, and you can put a key in there, and then you can also put a key underneath it. So you can also have a floating key like in the middle of nowhere, like a section which has keys and multiple keys of different hierarchies, and then values inside them. So they kind of match them. So like the ini file one matched directly to that, and then the section maps to log level.default. So you can just change them together. But everything comes back out of the providers as just a flat key. JSON file is pretty much similar, but obviously it's in a JSON file. So you have the hierarchy of the JSON file, but then every single subdocument or array within the JSON file, it just appends a colon to it every single time. So you just get a flat key, the same as before. And then XML files, exactly the same as JSON, except for it's an XML, so nice and simple. So environment variables are a bit different. You can replace the colon for a dual underscore, and this is for operating systems where they don't support colon. So I think Bash doesn't allow you to use colons as environment keys, and also it allows you the case insensitive allows you to use like any kind of standard for your environment variables as well, and that's pulled off another kind of NuGet package as well. That one. So this is how you kind of set up. Another extension method of add environment variable, And then you can also add like a prefix to it as well. So maybe you've got a bunch of applications on a machine and you want your application like product A to kind of only pull environment variables of product A and doesn't want to read anything else. This is how you can do it with just adding a prefix. So this is kind of some examples. So for the Twilio API key, where you've got Twilio at the top, and then there's a section, and you've got API key as a key inside that section. We can export in Bash with a Twilio __ API key and set the value. And in PowerShell on Windows, you can do the env Twilio _ as well, or you can just use a colon as well in Windows, and that works perfectly fine. User secrets is built on top of the JSON file provider, and the idea is it's for secrets which are your personal secrets for you to develop on. So instead of commit, how people commit their own username and passwords in config files and all that kind of things and all their API keys, this is a way for you to store your API keys, your username, passwords, or anything else like that, where you want to kind of store on your local machine and use them for the application running, but not commit them to source control. And it stores a JSON file in the middle of these directories. So on Windows, it stores it under like app data, Microsoft user secrets in a JSON file, and also on Unix-based systems, it stores in like a hidden folder, Microsoft user secrets, and then the same JSON file. And how it correlates them together, when you create initialize a user secret for that project, it creates a GUID in the CS proj, which gets injected into your assembly. So then it can marry up that GUID with the GUID of the path on disk. One thing to note is like these are not encrypted at all. So if somebody does steal your machine, then they'll get all your passwords or secrets or API keys what you're using. So I use it with caution over everything else. But the whole meaning for it is not to kind of go commit all your personal stuff inside your project you're working on. And yeah, so you set up exactly the same as pretty much every other provider. It's got another extension method, add user secrets. This time you either can pass it a type, which the ID for the secrets is part of, so you can use a generic argument, or you can just give it the assembly where it lives for the ID, to get the ID of that secrets. And it can support it being optional and reloading as well. And if you want to set this up in your project, you can go to your directory, your project directory, and do .NET user secrets in it, and that'll just go generate you a GUID and put it in your CS proj. And then you can also do a .NET user secret set, and then set a key and a value. You can list all your keys and values for that project, and then also you can remove it, and you can clear out all your user secrets as well. So you don't have to go manually in editing config files as well. You can write a script what your team uses as well to go ask them for all their secrets while they need to run the app, and it can just configure it all for you as well. One of the ones you can use configuration from configuration, which is kind of useful if somebody else gives you, if your project can take a configuration from somebody else's project, maybe creating some library, you can take their configuration as base default configuration for your configuration. So you can do things like taking a bunch of configurations, use the aggregate function, create a configuration builder, and just add all the configurations until the end and build it if you want to. This is actually used in the ASP.NET Core for the first one to create a first configuration what uses itself, and then it gives you a configuration what is built from their configuration. One of the things with the providers, ordering matters. So if we add a bunch of configuration providers, so this is adding 3 in-memory collections, the last one always wins, or the last one which actually resolves that key wins. So for this, for example, we've got an item, and then we've got 1, 2, and 3. If we try to get the item out of the configuration, it'll just give us 3. And because like most projects are built up with loads of different configuration providers, so you might be loading on from multiple files and disks, environment variables, command line arguments, or whatever else. There's a way to get a debug view of all the things what it knows about, which is quite useful. So once you've actually got an I configuration from building it, you can call get debug view, and then this will splat out a big massive string which tells you what all the values are and where they've come from. So for this, we've got like an event DDD, and then it tells you that's come from the memory configuration provider. And then we've got ini file, it says loaded from an ini file, and it says ini file provider and what file it came from. So it gives you a nice good description of like kind of where all them values coming from. So if you kind of got problems of like, why is this config not set, you can just figure it out pretty easily, which is quite nice. So, bit of code demos for that. So this is same as before. We've got a configuration builder here. This is setting a base configuration path because it needs to know where the files are. And then we can do add JSON file. We've got an app settings.json. We've got set to optionals false, and we've got a reload on change true. And then we've got the user secrets as well. And then we're pulling environment variables on Thunder as well. And then all we're doing is looping around and getting the configuration value of int. And then inside our configuration here, our app settings, we've got an int as well. So to start off with, I'm just going to, where did my program go? So I'm just going to run that. And that should just loop around every 2 seconds and get the current latest configuration value. So we've got 789 all the time. So if we go change this file to say this is, 9999 and save it, this will kind of update itself straight away without me closing it. But if I go and change this value in here to say reload on change to be false, and then run it, it will just give me 999. And then if I do change it to 1, it's not even JSON file, it'll just continue giving me 99 because it's not got the reload set. So if you want to force it to never kind of change after the first load, you can do that as well. So because our last one, what we added, was also environment variables, what we can do is set an environment variable in PowerShell as int. So if we set the environment variable to hello there and now run it, that'll take precedence over the actual config file. So then we've got hello there now. And we've also got user secrets. I think it's list. So it's got my fancy key 1 in there. But if we want to go set 1, so if we go, what else have we got in here? Oh, we can set anything. Actually, I'll just use that one. What's the load set? So we can go copy that key and we can just chuck it into here. And then when we run it this time, it will output 1, 2, 3, 4, 5. Yeah, from this fancy key, which is stored in my user secrets. And I'll just show you the actual how it correlates them together. So this user secret here, this one here, is how it correlates it to what folder it actually stores that JSON file in. So moving on. So web host defaults. So most people are creating web apps these days and web APIs and things like that. So .NET has a bunch of default configurations, what it provides to you when you kind of create a template. And one of these is in the program CS. So one of our files looks like this. And it has this host.createDefaultBuilder. And this does loads and loads of stuff under the hood for kind of setting up your application for you. And one of the things it configures is a bunch of default configuration for you. So this is the pipeline, the configuration, what it builds you. So it has an I configuration, which is their configuration, and it's injected into our configuration so we can use their configuration. So theirs has things like the ASP.NET like environment variable for the environment what you're actually running, so development, production, things like that. It also injects in app settings.json, so it's like a baseline configuration file. And then it also injects on top of that app settings.yourenvironmentname.json. And the environment name comes from these, either the ASP.NET core _environment variable or the .NET underscore environment variables. So that's where you get app settings.development.json, and people have app settings.production.json. So you can have your two distinct like kind of URLs and things like that for development and production. It also has app secrets automatically added into it as well, but only when you're in development mode. So if you run it locally, it'll add it. If you run it in production, it won't add it. So secrets don't actually exist in production because the idea is they're not really that secret. And then last of all, environment variables. So if you've got like things running in containers, you can easily override any of the settings by injecting environment variables into the container. Cool. So that's pretty much all about the providers and stuff. So next up is binding. So we've got these keys and values, which are just strings, which are useful, but not overly useful. So most of the time we want to be using like really complex objects with types and everything else. C#'s a statically typed language. So we want to take the configuration data and then get back an object from it. So an instantiated class. And this could have strings, ints, longs, date times, time spans, more complex objects on top of it, whatever you fancy really. And the binding stuff is all part of another Microsoft abstraction called, the binding stuff is actually built around the Microsoft extensions configuration abstractions. So that means if you did build your own configuration, like library, which implemented the Microsoft abstractions, all this binding functionality would work with your configuration provider. If we had a bunch of if your company were wasting time and built their own, they could use this library of Microsoft as well. There's also this concept of an option pattern as well, where you have like a I option of a type. And I'll talk about this later, but it's kind of recommended use for accessing configuration. So the idea is you say, I want to get this certain class of options, and it'll give them you. It's all strongly typed, and it kind of adheres to some good software engineering principles, such as interface segregation and separation of concern. So if you only want a certain amount of properties about that configuration, you don't have to get all your configuration settings and pass them all the way through your applications. So if you've got Twilio, for example, you only need your Twilio settings. You don't need to kind of expose everything in your configuration. So there's a bunch of ways to kind of use the binding stuff, and these are the simplest terms. So we've got our in-memory collection again there, and we've got a GUID where we set to it, which is just a string. And all we can do is just go get me a value, and you pass it the type you want to get and the key, and it'll give you a GUID back. We can also use a thing called bind as well. So what we can do is create an object, just any old object. You can set some of its properties itself, and then we can call bind, and this will inject the current configuration onto them options as well. So it'll go through all the properties. Say, have I got an int? Yes, I'll copy that across. Have I got a GUID? I'll copy that across. Another way to do this is using a section. So this has got a section of example. So I've got some hierarchical keys here. And then we can just do bind on that as well, passing the actual the section name as well. So that's quite nice and simple. And then the last one, we can also use get as well. So if we get a section from the configuration provider, so we get Twilio, and then we call get on it with our type of our object, it'll instantiate it for us and then bind all the kind of properties to it and passes back the object as well. So that's kind of how we can do that. And then this leads on to kind of dependency section and binding and options, because they kind of all couple together really. So this is kind of your normal ASP.NET core configuration for your services. So you'll register all your services in the startup CS. So you'll have to register some of our configuration. Say we have our options in app options. We can call .configure and then pass in our configuration object into it. Or we can also get a section and pass in that section into the configure method as well. And this will inject a few things into the IOC container for us. You can also do this handcrafted as well. So if you're not using the ASP.NET Core, you can literally create a service collection, a configuration builder, and then these methods will just work. You also need to include this Microsoft extensions.options.configuration extensions to get the extra extensions so you can use it if you want to that. So these are the bunch of things that get registered. So you get an IOption factory of T, and this has a bunch of default kind of things that get injected inside of that factory to create your options for you. So you get an iConfigure options of T, which allows you to configure how you configure them options when it first creates the options. You get an iConfigured named option. So if you're using named options, so you may have like 2 different Twilio settings where you might have one for, I don't know, company A and one for company B, and you want to segregate them. You can use named options. And there's also a thing called post-configuration options. So after it's bound everything, you can then access the properties and manipulate them even more. And I've actually used this in some people's libraries where they give you a bunch of configurations and you want to reload them or inject extra parameters into them configurations. You can use that. But most of the ones where you're going to probably use are IOptions of T options, which is going to be registered as a singleton, a snapshot version of it, and a monitor version of it. And then you also have a monitor cache as well. So the 3 what I just mentioned are kind of the most important ones, really, what you're probably going to use. So IOptions of T is registered as a singleton, and it's read when the app starts. And then you can, every time you read from that again, it's going to get the same values. And it supports named options as well. So if you've got like 2 different distinct company 1 using Twilio, company 2 using Twilio, you can do that in your code. The snapshot one is a bit different. It implements IOptions itself, but it's registered to a scoped lifetime. And every time you get a new scope from the ISE container, it then reloads the configuration at that time. So then you get a snapshot at that time. So if you think about your request coming in from ASP.NET Core from a web request, and you've got 3 classes what access like IOptions snapshot of my settings, you'll only create that once and you'll get the same configuration settings across that whole request. So that means if anybody's changing any configurations when the app's running while a user's request is going through, you're not going to get some weird mixed configurations. And that also supports like known configurations as well. So these are the interfaces from them. So yeah, there's IOptions of T, which brings back your options, which is a property of value. The snapshot implements IOptions, and that's pretty much how you can use it. So you can just inject it in as IOptions like in a constructor like normal. So fairly simple. And then the last one is the IOptions and monitor, and this is registered as singleton, and it's for registering change notifications. So when your configuration changes, you can say go do something, or go get the current value, or pop a toast up onto somebody's computer saying, oh, something's changed, restart this app because we can't do it for you. And that's kind of a way you can do that as well. So you just register a callback on the on change. So nice and simple. So better code, just to show that off. So demo 3. So this app here. So here we've got the service collection, what we just created, so we're not using ASP.NET Core. We're creating a configuration build like before. We're creating a JSON provider on top of it, which is not optional, and it reloads the changes when you change it. I'm configuring an example options, which is just an int and a GUID at the moment, so it's nice and simple. And then I'm configuring 2 of my kind of classes, my personal classes. I've created I've called one demo 3 app 1 and demo 3 app 2, and I'll show you what they look like in a minute. This goes and creates the service provider, so you go to the service collection builder and say go build it. And then we're just going around in like a while forever loop. We're creating a new scope, so this is simulating like a HTTP request coming into our web server. We're registering a service, we're getting a service called demo 3 app 1, and we're just calling execute on it, and then we delete it, and then doing it again and again and again, as simulating like it doing a request. And then the execute method of this takes in a IOptions. Oh, we changed this to just IOptions at the moment because I changed that last night. So this takes in the IOptions of example options. It goes and gets the value off that, and then just calls the int method on it. And that correlates to kind of our app settings here. So you have that int of 1. So it should just output 1 and this is a type of int. So it should bind it to that class with the right type and output it every single time. So if we just run that, let me just go. Was that actually an error, or was that just, no, that's good. So we've got the current int value is 1, 1, 1, which is great. So if we go to our app settings and try change it to 9999 and go back, it'll just continue being 1 forever because it's just registered as a singleton and it's not the snapshot version of it. But if we go back to that class where we registered it, and now we inject in IOptions of snapshot of t, the code doesn't change at all. It implements IOptions so you can plumb it into this value as well. It doesn't really care. And then we can run this app now. And then it should give me 9999. And then we can go back to our app settings and then just change this to 123, save it, and then we get 123 straight away because it's reloaded it. So and that just continues working, which is good. So the other one is the, let me just comment that bit code out, and then uncomment this bit code out. So the next one is the app2, and that just calls execute as well, but we'll just go look at the code of this one. So this plumbs in an iMonitor of t, and then we can get the current value of it. So the first time it executes, we're going to print out the current value what it's got, and then every time it's changed, we can say new value, and then print out the new value of it in this callback. So the callback gives you back the options as well. So if you now run that, so we got a big long number, I randomly just smashed the keyboard. And then we type in 123 as a real value. It'll change straight away, and it's got a bunch of new values. And then it's just replying back the current value. So it's saying the current value is that, and as soon as we go change it, it'll just get all the, I don't know why it's got so many, but you get the change notifications saying that that value's changed, and then you can do something with it. Cool. So now onto validation. So this is the kind of last section of this whole presentation. So validation is pretty good for like if you've got some configuration where you know it should be a certain, I don't know, URL of a certain format calling somebody's API, you can validate that. If it needs to be a value between a certain range, maybe you only accept a value between 1 and 100 for some parameter. Maybe you want to validate that that an API key is the certain string, so you can notify users as soon as they start up saying like, oh, the API key is in the incorrect format, you might want to do something. You can do that. So how this works is when you call .value on that configurations option, you'll evaluate the validation, and if it's invalid, it'll throw an options validation exception. And the validation can be set up in different ways. You can use normal data annotation, so if you've used ASP.NET Core, you can use the nice attributes of like kind of the range and stuff like that. You can use some inline validation based on a callback and use that. Or you can implement a interface called IValidate of t options. So if you've got some kind of really complicated like kind of scenario where you need to compare different values together, then that's probably the better one to choose from. So when we actually register the service, the options inside the service, you actually call something a bit different. So on this one, you have to manually call add options, pass in the options, bind it, and then call validate data annotations, if you want to use data annotations anyway. And then if data annotations are just like the attributes on your class properties. So for example, that's a regular expression, and that's a range for an integer. You can also pass in a delegate, so you can say validate and say the age has to be greater than 18. And you can also register a singleton of IValidate options, and then you can pass an implementation of it. So, and it'll kind of wire this up for you automatically. So it calls our validate method, and if the options are the options age is greater than 18, it's successful. Else it can reply back an error message as well. And this is kind of the usage of it. So in our app, we can inject in an IOptions snapshot. We can get the values out of it, and then we can just print the values what we've got. If we've got an error, he gets an options validation exception. Inside that, we have failures. So you might have a bunch of failures, and we can print them out as well and say what failed. So let's demo that bit. So this is pretty similar to before. We got the service collection. We just set in some base path. I don't know why we're setting that because it's in memory. Probably me copy and pasting. So I've got a name, an age on here. We add in these options of validation option, example options. We're binding it to the configuration. We're validating based on data attributes and also validating the inline one. So if we just comment this one out for the time being, I think, yeah, so if we comment that one out, so this is going to build the provider, get this current scope, and then get the required service of this validation app, and that's the one what you just saw on them slides. So the example is exactly the same as the slides. It's got a name and age, which are valid between certain regular expressions and ranges. And then we call dot value on it, and then it has this bit out here. So if we run this at the moment, it should work completely fine because I don't have an invalid name or an age. So if we do that run, that just comes back and prints my name and my age. That's not my age. But I can change this to, say, 10 for my age and do a run. And that'll come back saying data annotation validation failed for members of age with the error value age must be between 18 and 100. So it gives you a nice error message. So we can set that back to something else, which is valid. And then we can, I don't know, put some dashes in my name or something. And then run the same thing. And that will give me back a less friendly error message with an irregular expression. So that just says the field doesn't match the regular expression of any uppercase letter, lowercase letter. Yeah. So that's nice and simple. So if we change that back, if we comment out the data annotation ones, and this is how you just use the inline one. So this checks if the age is greater than 18. So if we set that to 10, for example, and run it, we'll just get a validation error. But because it doesn't know itself, because it's just a delegate, it can't give you anything more, a better hint of like what was invalid. It just says there was an error. So might be not so useful. So that's pretty good if you got your like some configuration what you want to validate at the start of your app startup. You can just add them kind of validation to your configuration, which is useful. Cool. So that's pretty much it. So I went through the basics of kind of it's just key values, and it has a concept of a hierarchy. We can pretty much pull data from anywhere you fancy. So if you wanted to go, I don't know, pull data from, I don't know, I have no idea, a web service, what you host, which is calling a HTTP request or something, you can go do that. The defaults for a web HTTP core are pretty good, so they come out of the box, and if you want to extend them on top of them, you can. And then we have all this kind of binding, dependency injection, validation on top of it as well, which is quite useful if you need it. But yeah, there's loads of stuff on the internet about this as well. So all the .NET configuration is in their docs, and then there's more stuff on the options pattern, what they provide in their docs as well. But yeah, thanks for listening. Does anybody have any questions?